Hey everyone, welcome to today's episode of the Cyberman show. Today's topic is all about identities and agentic AI and how it's impacting the security landscape. Now, before I get into the topic, my request to you would be to subscribe to my blog on Substack. It goes by the cyberman.substack.com. What I'm doing is I'm writing detailed blogs on whatever topics I am producing content of. So I write this detailed piece that you can take, save it as a note in your notebooks, or update it on Notebook LLM in case you are putting a notebook together on cybersecurity topics and want to do a deep dive than what I typically do. Okay. Secondly, also like, share, subscribe the content, give feedback. It helps to stay motivated as well as gives me ideas to create new content. With that, let's get started. So what I'm going to be covering today is essentially the impact of identity security because of agentic AI. Okay. So the topics will include what are AI agents, how do they work, what are the infrastructure components, the attack surface, then what are the common shortfalls of current identity solutions and protocols, then how is industry evolving to handle these shortfalls, and lastly the call to action. I've gone through a bunch of material, so I'm thankful to all the sources. So you'll hear a lot of names. These are startups as well as established companies and service providers who are building solutions, and I've referenced a lot of material while I created this piece. With that, let's get started. So what are AI agents? Simply put, they're softwares that use AI to pursue goals and complete tasks on behalf of users. So they are digital workers that perceive, decide, and act based on the goal that has been given to them. So they operate without little or no human supervision, and they can go beyond automation by setting goals, collaborating, and optimizing. Okay. Some examples could include chatbots involved in customer support, chatbots that are used in compliance, chatbots that are coding, or agents that are coding. Then in cyber, threat hunting agents, investigation agents are some of the things that I'm already seeing in the autonomous stock market, as well as if you go into details, a typical customer agent will deliver personalized customer experience by understanding customer needs, answering questions, resolving the customer issues, as well as recommending the right product or services to this customer. Okay, and I've seen a lot of adoption of these systems by enterprises, especially on the customer support side to begin with. Then what they're doing is they're creating agents to handle specific tasks based on the need of the business. Okay, but while we go into the identity side, also let's understand how are they working. So they have components. So all these agents, they have components for perception, reasoning, execution, and learning. Perception is all about agents collecting information from sensors, APIs, or databases. Reasoning is about using advanced models to plan what to do next. Execution is about carrying out actions by calling APIs, updating databases, sending messages, creating content, etc. Learning is all about observing the results, taking some feedback, and adapting to do better next time. Okay. Now, how this is getting achieved in terms of infrastructure components is by using a multi-layer approach. So a typical agentic AI infrastructure components include models. These include specialized models or foundational models, the orchestration layer that includes agent frameworks, memory state handling, etc. Tooling APIs that include connected to apps, databases, and SaaS. Data sources, these include structured and unstructured inputs, and how do we handle them. Execution environment is the cloud native layer that includes containers, the runtime functions, cloud workloads, etc. Observability, which that includes monitoring and logging pipelines. In fact, if you look up agent landscape in 2025, do a Google search on this string and you will find a good diagram that gives you the current state of how the agentic AI technology is getting developed. Okay. Now, let's look at the attack surface when agents get in picture. So imagine an environment where you have a user, a corporate user that's working on multiple systems. So he has an agent that is used for reporting on data in Salesforce. Then there's an IT chatbot that's built on OpenAI, and it's interacting with multiple systems, maybe using MCP to get specific reporting or work or tasks done within the external tools like Slack, Snowflake, writing some code or scripts on GitHub, then a co-pilot for making connections to the Azure cloud in case that's there, or whatever cloud. But essentially it's an environment where a user has access to multiple agents, and these agents are working independently or together to achieve the outcomes as desired by business. These outcomes could be reporting or automating the manual tasks done by multiple people together. Okay, so if in such scenarios, what happens is there can be multiple attack scenarios. So first thing could be fake agents can exploit weak authentication if it's not properly implemented. So this goes into the bucket of identity spoofing and impersonation as an attack surface. Second could be privilege creep, which is excessive permissions given to agents. Third could be lateral movement, which is compromised agents moving across domains that they are not supposed to access. Prompt injection and goal manipulation, which is giving adversarial inputs that change the behavior of the agents. Next one could be credential or token thefts, which is stealing secrets that enable unauthorized access. Next could be agent proliferation, which is dynamic or ephemeral agents untracked by security teams. And then delegation gap, which is unclear accountability when agent act on behalf of others. So right, so these are the problems that are related to agents. If you look at this in an enterprise scenario, assume every user is able to create their own agents to automate their tasks, and they can give permissions, access, connections to systems that could be permanent, could be temporary, and because they don't understand cybersecurity implications of giving these permissions to the agents, and this could lead to a bigger attack surface. Okay, now let's look at why current identity security stack is not able to handle these issues. Okay, the first one is, let's go back into basics, which is protocol. So today the most common protocols used are OAuth and SAML. OAuth stands for Open Authorization. It's a standard protocol that allows users to grant third-party application access to their resources like data or website or a service without, so the user doesn't have to share actual login credentials with the target app. The protocol takes care of it. The second one is SAML, which is about secure exchange of authentication and authorization data between two main parties, identity providers and service providers. So these two protocols are very common. Okay. Now the limitation of these protocols is that, one, they were designed to be human centric. So what that means is they understood how humans work, how they request access, and they were not designed to understand autonomous machine actors or non-human identities. Okay. Second, these protocols were designed to be relatively static. Somebody will request, a person will request, and some person will approve, and then the task will be taken or done. Okay. But in case of AI agents, they require granular task and risk adaptive permissions. Okay. So agents are dynamic in nature versus humans who work more in a static environment. The third limitation that this protocols has is continuous assurance. So AI agents demand ongoing authentication and authorization checks, not one-time login and long-lived sessions, which is what happens if you get a permission using OAuth and SAML. It's assumed that you are trusted, and then your permissions typically is not revoked. Okay. Then the contextual and behavioral signals. So traditional models emphasize on attributes and scopes. Agents, on the other hand, need policy decisions based on real-time context, behavior, mission state, and the input given by an agent or a human. And this is because of the dynamic nature of agents. the context is not there with the identity, these protocols. Okay, and similarly, because of these limitations of the protocols, the underlying identity stack that implements this protocol limits them. So this includes traditional IAM solutions like user directory access management, user lifecycle management, MFA and SSO solutions, privilege access management solutions, identity governance solutions. They were all designed to focus on the human users, not on non-human identities or machine identities. So this approach has to completely change, and it has to be evolved based on agents, because agents behave differently than humans, right? One, they spin up and terminate dynamically. Second, they require fine grade, just in task, time permission that is tied to a task. They act on behalf of users, other agents or systems. Also, they need continuous authentication, delegation tracking, and instant revocation to handle the cybersecurity risk. Again, summarizing whatever I've said so far, agents are dynamic in nature. They are ephemeral in nature. They will need different permissions. They will need different access levels, as well as inputs based on their goal, and their goal can get updated. Okay, and you can't wait for a human to approve this, otherwise the entire objective of implementing AI is wasted. Okay, now if you look at the specific shortfalls, and I'm going further deeper into the use case, is one, the traditional IAM systems, they lack real-time dynamic provisioning because they require manual intervention, manual approval mostly. Okay, course gained policies and role restraints exist because they don't adapt to agent context or task scope. There is inadequate delegation or on behalf of tracking, because when agents are performing actions for humans or other agents or other systems, they typically don't record the chain of delegation, undermining accountability. Okay. Similarly, the issue of credential management exists because APIs or certificates in many systems are rotated by humans, or every 90 days typically, but agents need secret rotation and kill switches the moment anomaly is detected. You can't keep running the agent if it has super user access for a long period of time. Okay, again, I've said this multiple times, but the agents don't have the traditional IAM doesn't have the contextual checks compared to what agent has, and it cannot recognize rogue agents or compromised identities because of this. Okay, so these are the issues, right? So if I have to summarize it in one statement, traditional approaches were designed to handle human first interactions, but the agents need a machine first approach. That's the crux of the statement. That's the crux of the lesson from today. Now, while we have spoken about the issues, let's look at how industry is evolving. So for past 2 years, I'm noticing a trend in the identity security space, where the entire architecture and capabilities are getting recreated, redesigned, and the core concepts are this. One is zero trust for agents, which is every agent interaction goes through a continuous authentication, least privilege enforcement, behavioral monitoring, and segmentation to minimize attack surface. So there are companies that are implementing those concepts, and I'm going to mention some of these just for learning purpose. The second capability I'm seeing is policy as a code and adaptive authorization. So that means real-time context and task-aware policies that are now available as a code. It allows differentiated access, automated anomaly detection, and kill switches. Second is auditability and explicit delegation. So every task or every action is traceable to a unique agent or delegating human. Okay, and let's look at some of the companies that are implementing this. So if I start with basic service providers, so example, Amazon Bedrock Agent Core has taken the approach of centralized identity management. So they provide unified agent registry, short-lived tokens, delegated authority support, as well as full audit logs that are integrated with CloudTrail. The approach is simple: provide a unified control and auditing of AI agent identity at scale. Let's look at Microsoft Enter Agent ID. So they allow or they have features of dedicated identity agent identity objects. The second is conditional access policies for agent, built-in logging and alerting, integration with Enter ID governance and entitlement management. So these are the two large CSPs. It's not possible to cover all CSPs. I'm generally going through what are the common ones. Then look at some of the dedicated IAM players. I found a company called Strata Mavericks. What they've built is just-in-time identity provisioning for agents, policy-driven context-sensitive authorization, delegation chains, runtime permission adjustment, continuous audit trails. Also, large players like Okta. So Okta now has a unified human plus agent identity fabric. So it includes agent lifecycle management, onboarding, offboarding processes, cross-app access protocol for AI agents, real-time least privilege enforcement, centralized logging and analytics. Okay. The next one is CyberArk, which is known for their privilege access management solution, and what they have built now is zero standing privileges for agents, secure credential injection and rotation, behavior analytics for off agents, as well as open source SDKs for secrets management. So these are some of the companies. I'm sure there are a lot of other companies that are there already. It's what I did is I used some of the names that are already there, and more are there in my blog. In interest of the time, I've just covered only some of them. Okay. Now, what are the call to action? So what we have done so far is understood what agents are, how they work, what are the components, the impact on identity, why there is an impact, how agents are different compared to a human approach. But in the end, if you're implementing agents, the first thing you should do is get visibility. So inventory all your agents, know what they are, who's issuing them, who owns them. Okay. Then evaluate our IAM stack. So verify if your current IAM provider supports agent life cycles, just-in-time authentication and authorization, as well as full audit. That's a bare minimum. Of course, implement zero trust for agents, which is implementing continuous verification, micro permissions, micro segmentation, etc. Then automate and governance. So use APIs, policy as a code, and behavioral analytics to secure every agent action. So this is the approach you should look for if you're going to implement agents in your organization. Okay. Also, if you are an architect, an AI engineer, please upskill yourself, your teams to secure agentic AI identities. Okay, this is going to be future. It's a big problem. We don't know the scale of it so far. We can only imagine today, but this will be a critical skill going forward. With that, thank you so much. I'm again thankful to all the sources, all the listeners. I'll see you guys next time. Till then, bye.